afternoon. I'm Gardner, and I'm a sophomore majoring in biology. So I did my internship, my undergraduate research with Dr. Simmons, and we were researching the earthworm species in our local ecosystems using the EREN worm protocol. Our objective was to investigate the abundance and diversity of earthworms in our local ecosystems because there's not much data on all of the worms that we have here. There's a lot up north, but not too much in the south. So we just wanted to see how many and what species of earthworms we do have. Some background. Earthworms are very important to our ecosystems. We all know that. They recycle organic matter nutrients back into the soil, and they oxygenate the soil and help the soil drainage through their channels that they create when moving through the soil. But all earthworms aren't good for our soil, which I thought was kind of surprising because I think of an earthworm, it's just this little creature, it can't do any harm, but it can. Exotic earthworms. So we found a lot of exotic earthworms while we were sampling, but they are not that great for our ecosystems. They can mix the soil layers, which can mess up the soil structure. Typically, they mix the topsoil and the organic matter, like the leaf litter, and they can also disrupt native species because if they're mixing the layers together, the native species are used to the leaf litter on the top and the topsoil. So if it's mixed, it can disrupt how they function in their ecosystem, and it can push them out. Our hypothesis was that earthworm abundance and diversity is low and sporadic due to patchy habitat structure. And we're just testing the null because, like I said, there's not much known about the earthworms in our area. We sampled 6 different sites, 5 of them are on campus. The first one that's on campus is the pond, which is an open grassy area. It is next to the Ezra Pond, and we sampled right next to the gazebo. The second site is the woodlot, which is a loblolly pine stand covered with pine needles and leaf litter. It has really compact soil, which isn't great, but they can't move around as well because of all the clay that is in the soil. We also sampled Hoopie dunes. The biology 1107 students didn't get to go there, but we did. And it has a lot of longleaf pines and wiregrass. It is covered with pine needles and leaf litter. The pine needles can make the soil more acidic, which we'll see later. And there's a lot of patches of bare sandy soil. Our fourth site is the campus site, which is a scattered hardwood forest, a lot of trees. It's behind the academic building, and the soil seems like it was recently disturbed. We found a few earthworms there though. Swamp Walk is right next to the City Fulford Center. It is really wet there. The soil is great for earthworms. And it's a bottomland hardwood forest. The Butterfly Garden is a secondary mixed forest with lots of leaf litter and sandy soils. Materials and methods. The first thing we had to do was make the frames. The frames are our sampling areas. There are 3 frames for each place that we sample. They are 0.6 meters squared, and the way we place them is we throw a tennis ball to find a random sampling point. It's very scientific. And then 5 meters from the central point, we place the first frame, and then the other 2, they're all placed 120 degrees from each other in 3 quadrants. In the frames, we do a vermifuge. Vermifuge, what the vermifuge is 60 grams of hot mustard powder and 6 liters of water. And we do that twice, so they end up with 12 liters of water and 120 grams of hot mustard powder. What this does is it irritates the worms, so it draws them up from the soil because they're trying to get away from the vermifuge. Once they come up, we start collecting them. Now, when we do the first vermifuge, typically we didn't see any worms at first. So we wait 5 minutes after the first vermifuge, and then we pour the second one. Once we pour the second one, we set a 30-minute timer, and as the worms come up, we gather them. And we would place them in cups with moist paper towels until we got them to the lab so we could process them. And we had flat forceps so that we could pick them up without damaging them. Once we got them to the lab, it's time to process them. The first thing we do is we make notes on their appearance before we do anything. So you can make notes like they're unpigmented, they're pigmented, or if there's anything special about their outer appearance, you make a note about that. You can make a note about how long they are, stuff like that. But after that, we euthanize them in 50% isopropyl alcohol. Once they're euthanized, it usually takes about 2 minutes, but they can stay in the euthanasia for a little while. It's fine. There's a fixative. The fixative is just to fix the outer tissues of the worms that might have got damaged during the euthanasia. And we didn't have that many problems with that, but for the bigger earthworms, it tended to mess with their outer tissues more than those juvenile earthworms. So they typically did have to go into fixative, which is ethanol, formalin, and glacial acetic acid. And they would have to go in there for 2 days. After that, they can be transferred to the preservation, which is 70% isopropyl solution. Once they're in the preservation, we can identify them using a dichotomous key, which was really easy. With all the data that we collected, I did a Chisquare test. We have the 5 different sites, an observed value and an expected value. Over here, we have the chi-square values and the sum of the chi-square values. The p-value for the chi-square is 0.000026, which is very small. And since that is so much smaller than the level of significance, we determined that there is a difference in worms between sites. There's a difference in the abundance. This shows the abundance of worms based on the soil pH. So on this side, it's more acidic soil, so there's not that many worms over here. But when you get more basic, you tend to start getting a lot more worms. And this trend line shows where they fall, and it's at 0.8829, which the closer it gets to 1, the better the value is for the abundance of worms based on pH. Now, they don't fall too far off the trend line, so there is evidence that there is more worms in more basic soil. The worm that we found the most was a Memphis, which is an exotic earthworm. So we found and sampled 54 earthworms, and out of those 54, 46 were a Memphis, which is about 85%. They're exotic and they're Asian origin, and they typically reside in the topmost layers of the soil, so leaf litter and the topsoil. The reason that the species is bad is that it can quickly consume leaf litter, which is bad for the trees and forest floor, but it's also bad for other decomposers that need the leaf litter to survive. And they're also parthenogenetic, which means that they are asexual and they can reproduce without a mate. So if you just take one Memphis worm and put it somewhere where there's no Memphis worms, eventually you could have a population of Memphis worms there. And there's no good control measures for getting rid of the worms. A Hoopie Dunes is where we sampled without the Biology 1107 students. But we didn't find any worms there. We did a vermifuge and found no worms, and then we hand sampled for 2.5 man-hours. So we dug in the dirt, picked up logs, we couldn't find anything. But the leaf litter is stratified, so you can visibly see the layers of leaves over time. So there's most likely not worms consuming the leaf litter in that area. In fall 2021, we plan to keep sampling and to continue collecting data on the earthworms in this area, and we will go back to a Hoopie to sample different areas. We only sampled at one area in a Hoopie dunes, but there are a lot more places we could sample. And we're also going to set up pitfall traps so we can catch other arthropods that are there so we can examine them too. I want to say thank you to the STEM for Cure grant for funding this undergraduate research, to Dr. Simmons for her time and for giving me this opportunity, to the biology department for the space to work and for the supplies, Georgia DNR for our permits to a Hoopie dunes, and the biology 1107 students for the research assistance.